So this is program in which we get idea about pointers. So first is main. Now int I is equal to 3, printf slash n address of I is equal to %u comma ampersand I. Now printf slash n value of I is equal to %d comma I. So in this program we get output about address of I, which is 65524, and value of I, that is 3. So this was program explaining pointers. Look at first printf statement carefully. And used in this statement, it sees address of operator. That means ampersand, that is, and is ampersand, which is used in this statement, is sees, that means C language, address of operator. The expression ampersand I returns the address of variable I. So this expression ampersand I is returning address of variable I. That means it is telling us address of I. Hence it is printed out using %u, which is a format specifier for printing an unsigned integer. So %u is a format specifier for printing an unsigned integer. We have been using the ampersand operator all the time in scanf statement. So in scanf statement we use ampersand operator every time. The other pointer operator available in C is star, called value of address operator. So another operator which is used in C is star. This is called value at address of operator. It gives the stored at particular address value. The value at address operator is also called indirection operator. So value of address operator is called as indirection operator. So this is another program explaining pointers. So main, now int I is equal to 3. Now printf slash n address of I is equal to %u comma ampersand I. So address of I is equal to %u. That means %u is used here, and ampersand I is used for address, showing address. Now printf slash n value of I is equal to %d comma I. Now printf slash n value of I is equal to %d comma star and I, ampersand I. The output of above program would be, so first output of address of I is equal to 65524. Now value of I is equal to 3 and value of I is equal to 3. So these are outputs of programs. Note that printing the value of star ampersand I is same as printing value of I. The expression ampersand I gives the address of variable I. So this expression, which is ampersand I, is giving address of variable I. This address can be collected in variable I. So this address is getting collected in variable I. This address can be collected in variable by saying j is equal to ampersand I. So this address is collected in a different variable, which is j. So j is equal to ampersand I. But remember that j is not an ordinary variable like any other integer variable. It is a variable that contains the address of other variable, that is I in this case. So j is not any other variable, it is variable that contains the address of other variable, that is I in this case. Since j is a variable, the compiler must provide its space in memory. So since j is a variable, the compiler must provide it space in memory. Once again, the following memory map would illustrate the contents of I and j.